Well, sir, this is my task to applied side presentation about standard normal distribution. We use the standard normal distribution, which is the z-world, because we can calculate the mean or standard deviation knowing the probability and one of them. So, for example, if we know the probability where x is greater than 9 equals to 0.4, we could use this, and if we know mean or standard deviation, we can calculate the other one. So if I knew mean, I would get standard deviation. We can also use this to compute and compare against other normal distributions. So for example, the normal distribution where the mean is 100 and the standard deviation is 5, we can use the z formula here to calculate which each x value would give. So for example, following this formula, 100 minus the mean, which is also 100, would be 0, and then divided by 5, which is still 0. So hence the z, which is 0. And this would be the same, except the first number would be 90, which is minus 2, etc. And the reason we can do this is because the normal distribution bell curve, so here, where the mean is 100, and let's say for this question, x is less than 90, so 90, we're looking at this area, which is the probability of 0.02. So essentially in the z-world, the bell curve, the area is basically the same for z is less than minus 2, because the mean is 0, and the standard deviation for the z-world is 1. And it's basically the same for all of these questions. So exam style questions. So an exam style question would be this one, which is taken from the exercise book. So for this exam style question, you're asked to sketch a graph, which is basically just the bell curve here, and you just shade in the probability regions, which is given here, 5%, 10%. For question B, you have to show the mean, find the mean and standard deviation. You first do this by writing down the probabilities, and then using the z formula here, you code them into like this form, and then rearranging the divide by standard deviation, you make it so the z number is times by the standard deviation, which is here, and you get two formulas. You use those two formulas and do simultaneous equation, and you will get the standard deviation here. You then substitute the standard deviation into one of the formulas, and then you can find the mean, like here. And for question C, it's basically asking you to do a binomial distribution. So you write down what it asks, so the mass is greater than 25, and then you basically use the you basically use the z formula to code it like so, and then you can find the probability. But since this is greater, and mass is greater than 25, you have to do the 1 minus to make it back to the less than. And then you could get the probability of the binomial distribution. And since there's 10 penguins, you would have to use 10 and the probability you got from this for the 0.33. And then you use the binomial CD function in your calculator, which is mode 7. And then you just put the 4, you have to change that into 1 minus p of x is less than or equal to 3, because it can't be greater than equal to. Putting this in the calculator, you get 0.55, and then you do 1 minus that for the greater than 4. So for question 14, question A is basically the same as question 13b, where you find the mean and standard deviation, which is this part of the answers. And for question B, it's a bit different. It's where you use the fact that quartile 1 and quartile 3, this is 0.25, this is also 0.25, which makes this whole thing 0.75 for quartile 3. Knowing this, you get the probabilities, and using inverse normal, you can get the z, which is minus 0.67 and 0.67. You then put in the formula where z is this, x is the unknowns, and then minus the mean, which you got from the question A, and over the standard deviation, which you also got in question A. Knowing this, you get the quartile 1 and 3, and then you just minus it for the interquartile range. The amount of unknowns needed to find affects the difficulty of the question. For example, these two questions, you need to find only one of them, where this mean the standard deviation, and you essentially just basically put in the calculator where you inverse normal and then use the function and you find the relative unknown. Compared to something like this where you have to find the mean and standard deviation, where you do the same thing where you inverse normal, but then instead you have to do another step, which means you have to do the simultaneous equation. A misconception would be the wrong way of less than and greater than. So for example, x is less than 9, they might accidentally put it into lower, where lower is 9 and the higher is 1000, when in reality the lower should be a really low number and higher should be 9. Another common mistake could be not realizing it's in continuous form instead of, and it's not discrete data. So for using this question again, they might accidentally turn it into x is less than 9.5 before they actually put in the calculator, which could be a mistake. It also links to other areas of math where you approximate to binomial. You could also have inverse normal from one of the exam questions. You could also integrate the bell curve. This is beyond A-level math, but you could basically integrate the bell curve, which is the Gaussian integral. It's where you integrate this with the bounds of infinity and negative infinity, which basically gives the area under the curve, which is the probability. Some real-world examples are when statisticians use standard normals to compare two distributions of data much more easily. For example, like they might want to code two people winning a game, which might have like different advantages and resulting in like different percentages of winning the game, and they might want to compare that. They could also transform the raw data into Z form to find the probability much more easily. And that's the end of my presentation. I hope it wasn't too boring for you, sir. Thank you.